Alright, so welcome back to the 988. Haven't touched this one in about 3 years, but when we last left off, we had completed all of the major components for it. So this time around, it's time to complete all the mini components, all the small little pieces like this Z-bar linkage, and make the railings and all the little 3D printed parts that are needed to finish off all the structural stuff for this model. And then it's going to be time to paint it and put the decals on it. The original wheels that came with the donor tires were hugely inaccurate, so I created some 988 wheels in 3D and then 3D printed them. 3D printing is something that I like to use for the small accent pieces. It's not something that I want to use for major components like buckets and booms and sticks and such, but it's really good for creating things like hydraulic cylinders and little handles for latches to get that little extra bit of detail that I can't get with my CNC machine, or that doesn't come out accurate enough when I do it by hand. It's been a pretty fun learning process, figuring out how to use 3D design programs and then subsequently figuring out how to use the 3D printer. The 3D printer that I use is what's called a resin 3D printer, so it's not the one that sits inside a gantry and ejects the plastic out onto a plate, which is called additive 3D printing. Instead, the 3D printer that I have uses a vat of resin and then uses UV light to create shapes in that resin, and it works out pretty good. It's really nice to be able to have some more exact parts. On the bottom there was the hydraulic tank that I created as well for this model. I will still try to use the CNC machine for as much stuff as I possibly can, but for everything else that I'm not gonna want to try to hand build, I will be using the 3D printer for. Something else that I learned a lot about during this project and will definitely continue to improve upon and build upon is how the parts that I create go together. And thinking about projects holistically from the beginning, visualizing how various brass components will fit in with one another, and if I'm using die-cast parts from a donor model, how those parts are going to interact with it, mostly for the sake of ease of assembly, and then also for that added accuracy. I find when I'm reviewing a lot of the footage of my work that I spend the most amount of time trying to fit things together. And later in this video, we'll see some lessons learned with how I pin things together. Up until now, I had kind of worked on these projects bit by bit and thought about the components separately. So thinking about how I'm going to build the bucket, then building the bucket, then thinking about how I'm going to build the arms to attach to that bucket. What I'd like to do with my next projects is think about all of that stuff from the beginning and make myself some notes and drawings or ideas or whatever it is that I need to think about how it's going to assemble as a whole kind of like how an engineer would think about the design and assembly of a car. They don't just design the engine and they go like, okay, we're gonna design the car around that. They think of all those components and pieces and how they're going to fit in together. And I think that being able to do that is really going to enable me to work through these projects a lot quicker, because it's all this tedious stuff like trying to fit all these parts together that really is the most time consuming part of the builds that I do, which is fine. It's all part of that learning process, but anytime that I can take an opportunity to improve a process with how I'm building a model is better, because it means that it's a much more enjoyable experience for me, because I'm not wearing myself out mentally trying to stuff stuff together, and it also allows me to get more of my projects completed, and maybe even being able to build some stuff for other people from time to time. I think of all the components that I built for this model, this front frame is definitely my favorite. It was quite a challenge finding all of a good set of reference photos for it, and then figuring out how all of those pieces fit together. Again, I don't have any blueprints for these. I don't get any exact measurements. A lot of it is just done through eyeballing, and then sometimes being able to compare it to parts from the donor model. But on the whole, I think it came out really good. There's probably some nuances in here that aren't quite accurate, but as far as the front frame of 988F is concerned, I think it came out really, really good. And just the amount of work that went into bending this thing up and soldering it together and stuff was really cool. I don't think I'd want to make one of these again, but as far as a practice, it was really neat. I decided to reuse the tilt cylinders from the 988B, but they were kind of wonky and they weren't very shiny. So what I ended up doing was putting them into my drill press and then using sanding sticks to buff them out and try to get rid of some of the inconsistencies in the surface of it. And it it turned out really well. I've used this in the past for other things like shining up aluminum for the exhaust pipes that were on the Peterbilt model. And again, they didn't come out perfect, but as far as something that's going to sit on a shelf, they came out really well, and it made it so that I can actually tilt the bucket. I'll show you guys that at the end of the video once the model's assembled. It's always a bit of a shame covering up all of the beautiful brass work with paint, but here we go. The 988F is unique in that it was offered with both the stick steer and the steering wheel, though the brochures that I found for the 988F do not make it very obvious that you can get a steering wheel as an option. They hide it down in the optional equipment list, and they give it a rather esoteric name like auxiliary steering unit, something like that. But the steering wheel was offered on both the F and the Series 2, but it seemed like most people opted for the stick steer. I went with the stick steer in the 3D model that I designed because I thought it was kind of neat that the F is the first one that got that option. So it was something that I wanted to try to see if I could create with the 3D program, and I think it came out pretty well. I also tried something completely different for the windows in this model. The glass that I cut out actually has a lip enabling the glass to fit inside the frame and be a little bit closer and more flush with the outer panel of the cab body itself, instead of sitting way behind it. And then for the gasket, I created that part separately as well. And once I get all this tape out of here, I will drop that part down in there. And for the masking tape, I used thinner strips of masking tape instead of using one large piece. It made it both a bit easier to install with accuracy, and then it also made it easier to remove without the risk of ripping the window out. And here is that gasket that was printed separately and just gets glued in on top of the glass. For pinning the model together, I elected to use brass rod and pressed it into all of the various holes to pin the model together. It worked out relatively well, but I need to think of a better way to do that in the future, because I ended up messing up the paint on the bucket and on the arms and breaking some components while trying to pin it together, just because it required a little bit more force to pin it together than I originally anticipated it would. When it comes to assembling my excavators, I have a different method that I use and it works out pretty well, but this was my first time doing a loader. So as you can see, the pin slots right in relatively well, but once it starts getting into the other part of the brass, I have to use a lot of force to get it in there, which worked out relatively well, except for areas where there was tight gaps, like the pins that are holding the bucket in. You can see the paint damage there that I had to go back in and fix later. Pinning the two structures together was another component that in theory seemed like it was going to work out pretty well, but once it all came together, I really had not a whole lot of room to work with in order to be able to try to pin those in, and there was a lot of pressure, so it ended up taking probably a good half hour, maybe 40 minutes to finagle all of this together in such a way that I wasn't going to break anything. The final result came out good. It still was able to articulate, but I needed to go back in with a drill bit and kind of ream it out a little bit more, and then install brass tubing in, and then sliding the brass rod into that tubing. All in all, it came out good. The hydraulic hose bank that I made was a 3D printed part, and unfortunately the weight from all of the hoses on it broke it, so I had to go back in and fix it with brass. Again, 3D printing's really neat, but it has its limitations as far as structural integrity, and that's why I really like to limit the use of it to stuff that's just for aesthetic, not stuff that's going to be structural. The decals I had to do in two parts because it has white lettering on them. I laid down a layer of white decal paper first and then dropped the other decal on top of that. Now you may be wondering, why don't you just do it all on a white decal paper? The reason for that is because I used an inkjet printer. So if I use my X-Acto blade and cut through any of the printed part, like the black ink, then as soon as I start to apply water to it, it will bleed out around the edges. So anything with color that isn't going to have a white border on it, like the stripe and the black and red stripe and the lettering for the 988, that all has to be done on clear so that I can leave a clear border on it so that the ink doesn't bleed out, and then I lay that down over a piece of white decal paper. It comes out pretty clean. It just takes a little bit of extra time to do it. The alternate way that I could do it would be to lay down a strip of white paint and then drop the decal over that, but it really isn't that big of a deal to just gloss up some white decal paper, cut out the size that I need, and then just lay the other decal out over it. I'm really happy with how the cab glass came out on this model. I think that's one of the biggest details in maintaining that sort of accuracy with a die-cast model, and overcoming the scale is being able to add details like the window gasket and windshield wipers, because it really makes it look a whole lot more realistic than when you don't have those details there. This project is hands down my biggest accomplishment when it comes to scratch building a model. It was definitely a lot more of a project than I originally anticipated it would be when I started it, but over the course of doing it, I was able to improve my skills a lot, and I learned a whole lot. I learned a lot more about using a CNC machine. I learned a lot more about 3D printing. I learned a lot about designing stuff with a 3D program and just getting like the scale of everything as close to correct as I possibly could. The model took forever to do, and it was one heck of a project, and I don't think that I'll be doing something this involved again for a while, simply because it took so much time to do and so much brain power. But as far as a skill builder and just something I could be really proud of, it definitely ranks way up there. This is one of those models that I'll never sell. It's going to sit on the shelf as a reminder of how much work that went into it, but it definitely is going to act as a barometer for what I can do moving forwards with some of the other projects that I have on the bench. And yeah, I'm just happy for how it turned out, and thanks for watching, guys. I hope you enjoyed the build, and there will probably be another video coming out here in a couple of months. See you guys then. Bye-bye.